Ready? I think jitter is gone now. X. Oh, very nice. Ready? Okay, I'm gonna pick the guys who never presented yet. Okay. 다정? She did once, but I think she's not here. 호진? No? Hojan is not here? Ask to unmute. Ask to unmute. Hojin, no? No response? Okay. Minus 0.5. Minus 0.5. Okay, Seungjae?
Yes,
okay.
Still calculating actually.
Okay. How do you calculate? What's your approach?
I'm using the y times 1.
Okay.
Sorry, yeah, trying thinking about it.
Minhang? Minhang maybe? Minhang?
Yes.
Ready?
I'm kind of confused with what Y means, but
don't worry about this, and only care about this question.
The jitter itself could just be we convert 50 to 0.05 because it's a second, and times 10 and times 30 for each frame.
All right, so let me solve the question. Anyone knows how to solve this in English or conceptual or not by the equation? Okay, what do I have? I have 50 millisecond late jitter per frame, and I have a 10-second video. Okay, my video is a 10-second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 1 second, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so per frame 50 millisecond, meaning per second, it is multiplied by 30, so it is 1.5 second. Meaning to deliver 1 second video, I have to have 1.5 second. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 7, 8, 9, and 10. Okay, everybody clear? So this is my downloading, and this is the timeline. Downloading, this is timeline. Let's say play this. What if I started to play after 6 seconds? Then I can play 1 second. First one, okay, checked. 2, checked. 3, what do you mean checked? 3 is already my buffer. Then I can play with this. 4, I can play. 5, oh, I can play. 6, oh, I can play. 7 is catching up. Okay, I can play. 8, no problem. And 9, okay, I can play. 10, oh, after a buffering is 6 seconds, I have no issue. Let's play at 5 seconds, after 5 seconds. 1 second, okay, check again, no problem. 2, no problem. 3, no problem. 4, no problem. 5, no problem. 6, okay, no problem. 7, okay, no problem. 8, okay, 8 is just buffer, so no problem. But while I'm playing 9, I'm still buffering somehow. And 10th, I'm not able to play it, right? I have an issue. And what if I am starting at after 7 seconds? It should be no problem because 6 seconds was not issue. And 5 seconds is not working, 6 seconds start to working. Ah, this is the conceptual meaning of this. Go back to the slide. Everybody understand this? Okay, so let's memorize it. So I have jitter 50 millisecond pop frame and 10-second video at 30 fps to be transmitted. Ah, if I have 6-second buffer, I won't have any issue, right? We just watch. Okay, if I have a 5-second buffer, I'm not able to watch properly at the end. Okay, clear? Okay.
So the amount of seconds that has to be buffered should be calculated based on the jitter ratio, right?
Okay, so the good point. So question says, I have calculatable 50 millisecond jitter. Okay, per frame, meaning if I have to play once, if I have to deal with the 1 second video, I have to consider as 1.5 seconds. Clear on this?
Okay.
Okay, then how can I play the video without buffering, without issue, without pausing it? Then your buffer need to be, your video must be buffered before I start to play. Your frame need to be buffered before I start to play. Clear? So if some buffers are framed and buffered, some frames are buffered, I can play the video without an interruption. Without interruption. Okay. So in the picture-wise, that is what I explained, and by equation-wise, you can calculate how much frames do we need. Okay, and we just solved it conceptually and by the equation. Clear? Maybe this equation is just the, not that important, but the conceptual wise, that is more important. Is this satisfied your question? What's your name, please?
Janar.
Janar? Okay, thank you. Any question? Okay, so let me start new slide. So I want to continue encoding and framing. Okay, so why do you need the encoding and framing? So this is actual word, how the network works. Let's say from the source, from your contents, then to your destination. So we do a source encoding and channel encoding, interleaving, and encoder modulator, then reverse way, the corresponding decoding, corresponding de-interleaving, corresponding decoding, corresponding decoding. Why do we need this? Okay, let's talk about this. Why do we need this? Let's say I sent the, I want to deliver to Janar about this information. Hey, hello, Janar. What does this message is converted to as somehow bits in the physical world, 10, 10, some pattern. Some pattern is delivered. Then over the analog, let's say some point is wireless, some point is lossy. Okay, because I have to travel at some point analog. And it is delivered. Then it won't be an issue, right? But in real world, what's happening? So the receiver has to have ability, what is a 1 and what is a 0. Therefore, what do we do? So 1 means 1, 0, 1, and 0, and keep repeating. To do that, I have to sample it. 1, 2, 3, 4 times. Oh, this is 1. 1, 2, 3, 4. Oh, this is 0. 1, 2, 3, 4. Oh, this is 1. 1, 2, 3, 4 times. This is 0. Okay, I'm repeating this process in your computer. So multiple sampling of the same data we call the oversampling. In a digital world, to make a digital word properly, we usually have 10 times of oversampling to confirm it is correct data. Okay, so what happened if I keep sending a 0, 0, 0, 0, 0, 0, 0? Okay, what do you do? Hey, Janar, what's your phone number? 0, 0, 0, 0, 0, 0. Oh, how many zeros? 0, 0, 0, 0, 0, 0. How many times is it? I think it is 6 and 5. You have to confirm it. What if the information is my phone number is 523-2513? It's much clearer than 0, 0, 0, 0, 0, 0, 0, 0, 0, right? We human can also experience this, but at the same time, your network and your computer is also experiencing this environment. So when the information is continuous zeros or continuous 1, it's very hard to recognize it. So when we're sending information 0, we are not sending 0. We are sending some pattern. This is pattern for 0, and we are sending some pattern for 1. Something like this. Therefore, if you're receiving some lossy environment, I can guess. Oh, I just received 1, 0, 0, 0, 1. What is it? Guess what it is? It's a 0. How do you know? I'm confident that 80%, I'm 80% confident it is a 0. And if you compare it to this guy, I'm 20%, because only this one is matching. I'm 20% confidence to a 0. Confidence to 1. Do you understand what I'm saying? So for the communication, I'm not sending 0 for 0. I'm not sending 1 for 1, but I'm making additional information, some pattern. Therefore, the receiver can understand more easily. This is how your network is advanced over the year. Okay, go back to the point. So the P2P, the direct link, the simplest network. So costing 2 hosts and 1 link, host A and host B. Look into the different function at the link. Encoding, why do we need encoding? If I'm just sending it, there's a high probability it is not able to decode it properly. Framing, why do you need the framing? Oh, I have to send this amount of information, but I cannot send it as it is, but I have to divide it. I have to make it pieces, then it can deliver over the network. That is framing. And error detection, error correction. Oh, since I'm used to encoding with the redundancy information, I have ability to error correction. I have ability to error detection. Oh, something is not good. Okay, we're gonna talk about this. And reliable delivery. If I just sending 10101110 like this pattern, the receiver is very hard to understand properly. Is it or no? Is it or no? Right? Even in a very short communication range, maybe it is not correct, but if you think about the Earth distance, if I'm called in New York from here, the information, I need to have reliable delivery. Okay? And MAC is media access. I'm sharing my AP's access point with multiple guys. How can you share it? What is the best way to do? That is a MAC. Okay, so this slide, we're gonna talk about this. So typical communication, okay. Typical communication works in this way. Source encoder does compress the stream of bits, and source encoder add redundancy to detect and correct errors at the receiver. Bits are mapped to the code word. I know what the code word. 1 is code to 10110. 0 is coded to 01001, something like this. And this is not a good pen. 01101, something like this. And scrambles the bits of the consecutive code word to spread the burst error. Meaning, we're gonna talk about this more. The scramble, why do we need to scramble it? So let's say information is 0111111, something like this. That is no good point. So I have to scramble it, then information is distributed. Okay, we're gonna talk about this more. And convert stream of bits, analog signals modulate for transmission over the media. Okay, so we're gonna talk about in this slide, and I think we can start discuss on next Monday. Okay, thanks for the slide. Any question?
Will there be a homework assignment given out today?
I will try, but it will be a little delayed, maybe tomorrow. But I'll definitely give you the homework earlier than this Friday.
Okay, thank you.
Yeah, homework is, I think I introduced how do you do homework. So homework, we're gonna use Anaconda. And code is written in the Python. Okay, so I'm sure you know how to using Anaconda, right, everybody? Jupyter Notebook. That's what we're gonna use for the homework.
Same as 373, right?
Yeah, same as 373. Right.
Okay.
Okay, if you're not familiar with the homework, please team up. Please find your classmate who can help you somehow. Okay, helping you somehow is not meaning the copying code or sharing the code. Or helping you is you are stuck in some technical issue or some algorithm issue. You may consult with your teammate. Okay, so I highly recommend you start early. If the homework is given, then you can have more chances to communicate with me and communicate with your fellows. Okay, all right, thanks for coming today, and see you on Monday, and I will try to upload the homework earlier than this Friday.
See you, Professor.
Thank you.
Thank you, Professor.
Yeah, thank you.